Hello class, this is instructor call. Here is the second part of our stoichiometry and molar mass worksheet. So we have gone over the first three sections in video 1, and now I'm going to give you an example of the next two sections. So here is an example of the second to last section on your worksheet. It says determine the number of moles in the following molecule. So make sure we're in the same spot. And the first question of 3 that you're asked is about 54.2 grams of N2. So the first thing we need to decide is what we're going to do. So we're determining the number of moles. And right now we're in grams. So there's our problem that we need to solve right here, is converting 54.2 grams of N2 to moles. So the first thing that we're going to do is get out of grams so we can get into moles. Remember that any whole number can be put over 1. I find that the easiest way to remember. If I then multiply or divide when I'm going from grams to moles. So now you know that to be able to cross cancel grams, that your grams is going to be on the bottom, and that way we can cancel them out, and that we want moles to be our final answer. I have a little cheat over here from our periodic table. Nitrogen has an atomic mass of 14.007 and its atomic number is 7. Okay, so going back to our problem, 54.2 grams of N2, we're going to get out of grams and into moles. Now we know that there is 1 mole in X number of grams. So let's come over here to our periodic table and figure out how many grams there are per mole. So the atomic mass of nitrogen is 14.007. And so we have N2 here. So we're going to double that. And we are going to get 28.014. And we're just going to round this and call this 28.01. Okay, so I'm going to write 28.01 right here. So there is 1 mole in 28.01 grams of N2. Now again, we cross-canceled grams so that our final answer would be in moles. That tells me again if I'm going to multiply or divide. Since it's on the bottom, we're going to divide. And we are going to get our answer of 1.93, get this out of the way, 1.93 moles of N2. And that's our answer for the first one. Okay, go to the very last section of your paper. This is the easiest section of them all, even if it looks scary. All right, determine how many atoms are in the following element. We're given 1.2 moles of strontium, and we want to know how many atoms there are. So again, I'm going to take my whole number and put it over 1, just so I can visualize my fraction. And I'm wanting to get out of moles of strontium so that I can cross-cancel and put my final answer into atoms. Here is the easiest part for all 3 of these questions. You know that there is 6.02 times 10 to the 23rd, there's Avogadro's number, atoms in 1 mole of anything. So we now times 1.2 by 6.02 times 10 to the 23rd, and really quickly we get 7.23 times 10 to the 23rd. That's how many the atoms there are. Now, hopefully you're saying that was way too easy. And why did she choose to use an example of an element rather than a molecule? Because if you look at your paper, the first example or the first question you're asked is about strontium. That's going to be an element. And the next question is about carbon monoxide. Do you see it? Look down, you'll see it. It's the same problem. So you're given 0.5 moles of carbon monoxide. Excuse me. All right, so we have 0.5 moles of carbon monoxide, but the rest of the problem is going to be the same for the second example and the third, and any test questions that you could have about determining the number of atoms or molecules. There is going to still be 1 mole of carbon monoxide to 6.02 times 10 to the 23rd atoms. So now all you really did was change this number right here. And that, we're going to cancel out our moles of carbon monoxide, moles of carbon monoxide. So for the second question, you're just going to times 0.5 by 6.02 times 10 to the 23rd.